All right, these are the notes for section 9.4, rationalizing the numerator in our unit of the algebra of calculus. So let's do a very quick algebra review here. So when you have a square root and you're squaring it, what that actually does is eliminates the radical. So in this example right here, when you're squaring the 7x under the radical, what happens is this literally just becomes a 7x. When you take a square root times itself, in this example over here, it literally just gets rid of the square root and you only have what is left over underneath your square root. Okay, this is something that you guys already know, but I just wanted to refresh your memory because we're going to be using this idea in a little bit. All right, the next vocab word we have is conjugates. We've talked about conjugates before when we did imaginary numbers, but basically what it is a set of binomials that has the same terms, except one is a sum and one is a difference, which means one has a plus sign and one has a minus sign. And now we have to be very careful here because this is a set of binomials, which means it's just two terms, okay? So look at each one of these sets of binomials here. These are sets of conjugates. So you have a plus b, and then you have a minus b. Your terms there are a and b. Same thing for the next one. You have x minus 5 and then x plus 5. You have the square root of x plus 3. This should be the square root of x minus 3 separately. That's a typo. My bad. Okay. All right, and then in the last one, that's the only one that I want you to be careful with. It looks like there may be three terms here, but you can tell that the square root of x minus 1, this is one term, and then the minus 2 is the other term. Okay, so same thing in the next one. Square root of x minus 1, that's your first term. Then there's a plus sign, and then your 2 is your second term. Okay, so just be careful. Just because there's a minus sign underneath a square root does not mean there's three separate terms. The square root counts as one term itself. Okay, so let's actually talk about what happens when you multiply these binomials together. Okay, when you multiply the conjugates, you have to basically multiply or double distribute or FOIL, whatever you're comfortable saying, to multiply out the conjugates. Your middle term is actually always going to cancel. So let's show what happens when we use example 1. If we're going to take the process of double distributing, so a times a times negative b, that would be a squared minus ab, and then b times a and b times negative b, so plus ab minus b squared. Okay, your middle terms right in here are going to be opposites, so those are going to cancel right away, and so your final answer would just be a squared minus b squared. Okay, also the same thing for number 2, x minus 5 and x plus 5. If we double distribute, you're going to get x squared plus 5x minus 5x minus 25. And again, your middle terms here are going to cancel, so you just have x squared minus 25. Okay, these are familiar to you. These are algebra concepts. You guys already know them. But what happens when we introduce a square root again? Okay, so again, this should be just the square root of x minus 3. Sorry, typo, and I'm too lazy to redo it and re-record this video, so you get what you get. So I'm just going to rewrite this: square root of x plus 3 and square root of x minus 3. That's what the problem should be. Okay, so let's go ahead and multiply these out. We know that our middle term is always going to cancel. We literally just showed that, okay? So because of that, I'm not going to worry about the middle term. I'm just going to take the square root of x times the square root of x, which becomes just an x, and then positive 3 times negative 3 minus 9. X minus 9, that's it. All right, same thing for the next one. I'm going to take the square root of x minus 1 times itself, square root of x minus 1, which will just give us x minus 1. We just talked about how when you take a square root times itself, it gets rid of the square root. Then we're going to take the negative 2 times the 2, and you get negative 4. And then we just simplify what we have left over. So we would have x minus 5 when you multiply those conjugates together. All right, So next thing we have on here is rationalizing your numerator. So sometimes, depending on what the problem is, when you guys get to calculus, you will either have to rationalize the numerator or denominator. So we're going to talk about what rationalizing really means, which essentially is just removing the radicals from wherever they are. Okay, so in order to remove a radical, you need to multiply the numerator and denominator by the conjugate of the expression that has the radical. Okay, so if I look at number 5 here, it says rationalize the following expression. I can see that there's a radical in the numerator right here. So I want to think about what is the conjugate of the expression in the numerator. Well, the conjugate of the square root of x minus 3 will be the square root of x plus 3. And you have to make sure you multiply top and bottom by that whole expression, because remember, you really are only multiplying by 1, so you don't change the fraction. All right, so the numerator, when I multiply those two together, since they're conjugates, I'm not going to worry about the middle term, and I'm just going to focus on the first two terms and the last two terms. So that means on top, I will now have just x, and then minus 9. And then the denominator, I'm going to leave it in factored form like we've been doing. So 5 times parentheses, square root of x plus 3. And we're going to leave it just like that. So I know it's unnatural to you guys to leave a radical in the bottom, but for the purpose of this lesson and what we're doing here, we're just going to leave it the way it is, okay? At this point, what you would do is see if you can either factor or simplify something from top to bottom, and then you would cancel if you could. Okay, so let's do the next two problems. All right, so we got number 6 and number 7 here. We'll start with number 6. So in the top, I have the square root of 9 plus h and then minus 3, so I do only have two terms there. So I'm going to multiply by square root of 9 plus h and then plus 3 on top and bottom. Okay, so let's just focus on first term times first term and last term times last term. Those are the conjugates. So on top, I now would have 9 plus h and then minus 9. All over your denominator, which we're going to keep in factored form again. All right, and so now at this point, you're going to cancel anything that you or combine like terms. Well, I have a positive 9 and a negative 9, so those are going to cancel right away. So now I just have h over that whole denominator. So h, square root of 9 plus h, and then plus 3. Well, the h's are going to cancel for sure because you have one on top and one on the bottom. So now my final answer here would be 1 over square root of 9 plus h plus 3. And we're going to leave it just like that. All right, last problem on the notes today. Okay, I have two terms in the numerator, so I'm going to multiply by the conjugate, which would be the square root x plus h plus 5, and then plus square root of x plus 5. Keep in mind, when I multiply by the conjugates, I'm not changing any of the signs underneath the radicals. I'm only changing the sign between the two terms because you don't want to change those terms. You just want to change the sign, okay? All right, so let's distribute. So top first two and last two. So now on top, I would just have x plus h plus 5. And then I would have minus. Now, here's where you got to be careful. The minus sign, you need to put a parentheses, right? Because you're taking like a negative 1 times positive 1, and then you have what's underneath. So you need to make sure you put that in parentheses and then put what's underneath, okay? All right, so we have h and then our whole denominator. X plus h plus 5 plus square root of x plus 5. All right, so I'm going to distribute in this negative here. Okay, so on top, I now have x plus h plus 5 minus x minus 5 all over my denominator of h, and then x plus h plus 5 under a radical plus square root of x plus 5. All right, I am going to look up top. I see I have a positive x and a negative x, so I'm going to cancel those. I also have a positive 5 and a negative 5, so I'm going to cancel those. So all that will be left over on top is an h, but I do have the h on the bottom, so I'm going to go ahead and cancel that as well in one step, just because I ran out of space. So now on top, I just have 1 over that whole denominator, square root x plus h plus 5 plus square root of x plus 5. Okay, and this would be your final answer here. All right, that is it for the notes for today. So your homework is just to try these two problems on your own and bring them back tomorrow. Okay? If you have any questions, feel free to email me. Hopefully, I'll see you guys soon. Bye.